Assalamu alaikum. I am Mihnaz Akhtar, lecturer, Department of Physics, Milestone College. Today I am here to take the online class. Because of the coronavirus, we cannot take the classes in the classroom. The coronavirus cannot affect the students. We are doing these online classes in this purpose. Because social distance must be needed for the prevention of this virus. And students must follow the rules and instruction that was given by the Health Ministry. So let's start today's class. Here I am going to discuss about a board question which is came in Dhaka board 2016. In this stain you can see that velocity and time, the values are given. When the time is increased 0, 8, 16, 24, 32, 40, 48, the velocity is also increased. 0, 4, 8, then it's stable 8, 8, and after that it decreases up to 4 and 0. It's all about the stem. Now let's have a look at the questions. What they says, what is dimension? The A-marks question says what is dimension? That in any physical quantity, the power of the fundamental quantities present in it is called the dimension of that physical quantity. And in the B-marks question it says that what do you mean by instantaneous speed? Instantaneous means all on an instant. And the speed is basically changing its position with respect to some time, and it is a scalar quantity. That's why it does not has any direction. So whenever a car is moving from one place to another, then there is a speed, and if we want to know all on an instant, suddenly the speed after 2 minutes, just 2 minutes, just 1 minute, that means all on a sudden. That is the time interval is very less. That's why we can say that that speed is called the instantaneous speed. C-marks question said calculate the distance traveled by the car within first 32 seconds. So we have to find out where the 32 seconds is. The 32 seconds is over there, and here we can see that from first 32, that means it started from 0 to 32. And here in the data we see that when it's 16 seconds, its velocity becomes 8, and after that it is uniform. That means it is not changed. So from 0 to 16 seconds we will find out the distance at first, and after that when the velocity is unchanged, that means uniform, we will find the distance again, and we will add these two distances and get the distance for the 32 seconds. So we will do it now. So here we will write the data at first. Here initial velocity, this is for first 16 seconds, u equals to 0 meter per second. Final velocity v equals to 8 meter per second, and here the time t equals to 16 seconds, and we have to find out the distance s1 equals to what? We will use the formula here. We know s equals to u plus v by 2 into t. Initially it's 0, final 8, 2 into 16. That means 64 meter. This is for first 16 seconds. And after that the velocity is unchanged. So we will use here again s2 equals to vt. vt2, and we will use here v1. So velocity v1 equals to here unchanged velocity, that's why it is 8 meter per second, and time t equals to here 16 seconds, because first 16 seconds we already have, and after that it is 16 seconds. So it is 8 into 16, 128 meter. So here one distance we have, here another distance we have. We have to add both distances to get the total distance. So s equals to s1 plus s2. 64 plus 128, it is 192 meter. So this is the distance for the first 32 seconds. Let's have a look what the D-marks question says. According to the given stem, draw the curve and explain the nature of velocity for different parts. So we have to draw the curve with these values which is given in the stem. So we will draw the curve at first here. Here I'm giving y and x axis. In x axis we will give here time t second, and here velocity v meter per second. Now we have to see here the duration. Here you can see that in velocity it is 0, 4, 8. So I am giving here 0, 4, 8, 12. And here 0, 8, 16, 22. So interval is 8. So we use here 8, 16, 24, 32, 40 and 48. Now I am drawing this line. You can use the scale for this purpose, or you can draw it in your own. No graph paper should be provided during exam time. Now it's easy to identify the points. So at first it is 0, 0. So I am giving here this point, which is 0, 0. And after that 8, 4. So velocity is 4 and time is 8. So this is the next point. And after that 16, 8. So here 16 is the time, second, and 8 is available here. And after that 24, 8. 24 second here, and 8 is there. And after that 32, 8. Here 32 and 8, and 44. 40 is here and 4 is in this way because here is 4. So this is the point. And the last point is 48, 0. 48 and 0. So here 48 and it is 0. Now we will join the lines here. After joining the line, the figure becomes this way. So we can give here the name of the points here, A, B, C, D. Now this is the half portion of the question done, because it is said that draw the curve. But after that we have to explain the nature of the velocity in different parts. Different parts means I am giving here the name A, B, C, D. So I have to explain the parts one by one. At first for AB, we can write for AB, the velocity is changed. It is increases. When the time is increased, then velocity also increased. And here you can also see when the velocity is increased, the acceleration also increased. And in the BC part, the velocity is unchanged, that is uniform. If there is no change of the velocity, then acceleration becomes 0. That's why we can say that in BC part, the acceleration must be becomes 0. Now let's have a look for the next part, which is CD. In CD part, you can see that when the time is increased, the velocity is decreased. That means deceleration occurs in this portion. So we can say that in AB part the velocity is increased and acceleration is over there, and after that in BC part the velocity is unchanged, that is uniform. That's why we do not find any acceleration in this part where the acceleration becomes 0. And in CD part we can see that as the velocity decreased, we know that the rate of decrease of velocity is deceleration. So here the value of the acceleration becomes negative, that means it is deceleration. So in that way you have to explain each and every part after this drawing. Basically this question has two parts. One is draw the curve and another is explanation. So at first you have to draw the curve. This is the first part what you did at first, and after that you have to explain why and where the velocity is unchanged, where it is changed, and where it is decreased, where increased. In that way you have to explain this. Then you can get the full marks in this question. Now we are going to discuss a board question again, which is came in Select Board 2016. Let's have a look what the stain says. In the stain you can see that Mukul was throwing a cricket ball straight upward with initial velocity of 20 meters per second. That means he is throwing a ball upward with a velocity. At the same time, in that time, from 30 meter distance, Nishan was running to catch the ball. That means the position where the ball is throwing upward, from that 30 meter distance, another person who is Nishan is coming to catch the ball with a velocity of 6 meters per second. That's all from the stain. Now let's have a look at the question. At first, the A marks question says, what is pitch? Pitch is related to the screw gauge. You already learned about the screw gauge from the chapter 1. If the cap of the screw cage is rotated, then the distance or displacement it covers on linear scale is called the pitch of that device. That means the screw cage. Here we have the BMarks question, which is said that power is a derived quantity explained. So we have to know at first what is derived quantity. The quantity which cannot explain its own self. It's need fundamental quantity to express. So power is a derived quantity because power P equals to W by T. We know that. That means work divided by time. So power is dependent on work and time, and work is dependent on force and distance. Force is dependent on mass and acceleration. That means actually the quantity which is depend on the fundamental quantity. Time is a fundamental quantity, and here we know the length or height, that is also fundamental quantity. So they are related each other. That's why you can say that power is a derived quantity, because P equals to W by T. We know that. That is work. So work is also dependent on force. In that way we can say that power is a derived quantity. We have to explain this. After giving the definition of the derived quantity, we have to explain the power in that way. In Siemens question, we can see that at what maximum height the ball reached. That means we have to find out the height. When the ball is throwing upward, we have to find out the height. Just think that when ball is throwing with the velocity, that means the initial velocity which is available here, 20 meter per second. So the ball is moving from 20 meter per second, and after maximum height it comes down. So in maximum height the velocity must be 0. That means if the initial velocity is 20 meter per second, then in maximum height the velocity, final velocity must be 0. That's why we can write the initial velocity is 20 and final velocity is 0 to reach the maximum height. So here I am giving the data here. Here initial velocity u equals to 20 meter per second and final velocity v equals to 0 meter per second. And in that question we have to find out the maximum height, h equals to what, and acceleration due to gravity, g equals to 9.8 meter per second square. It is the fixed value, we all know that. Now we will write the formula here. We know v square equals to u square minus 2gh. You can use this minus here, or if you are using here plus, then you have to write here minus. Why? Because you are throwing something. That means it is work against the gravity. So that's why gravitational force, and that's why you have to write the value of g is negative. When it is falling down, it must be positive. When you are throwing something, the value of g must be negative. So I'm writing here and putting the values here. We have to find out h, so I'm writing all together. So this is the value for the maximum height. We have to find out the maximum height. Here h is 20.408 meter. After giving this data and putting these values here, we get the value here. In BMarks question, it is said that whether it is possible for Nishan to catch the ball. Analyze the statement mathematically. So Nishan is able to catch the ball or not? This is asking in the BMarks question. Nishan is at 30 meter distance from the position, so we can find out the distance covered by the Nishan so that we can identify the ball is catched by him or not. For that we can think that when the ball is in air, that means at maximum height, then the height has become 0 because it was not traveling anywhere, it is in the air. So at that position the value of g is also negative. In that way we can find out the time period. So we can write here the data at first. Here initial velocity 20 meter per second and acceleration due to gravity g equals to 9.8 meter per second square. So quickly go down. Let when the ball is at in air, the time is T. So at T second, let the ball was in the air and time is T. After T second, its height h equals to 0. So I'm putting the formula here. We know ut minus half gt square. Changing the side. So here I am writing t square into 9.8 by 2, which is available here, and it is minus, that's why I am keeping it in that side. T is deducted from both sides, that's why t equals to 2 into 2, 20 to 2 divided by 9.8, and the value came 4.08 second. So this is the time. Now we will find out the distance covered by Nishan. So distance, it is uniform, that's why I am writing here Vt, and the velocity of Nishan is 6. So the answer came 24.48 meter, and here you can see that he is at 30 meter distance from that position of the throwing ball, but he covered 24.48 meter distance, so it is not possible to him to catch the ball. So I am writing the conclusion over there. So Nishan cannot catch the ball. You have to write the conclusion, otherwise 1 mark should be deducted, because the conclusion contains 1 mark. So write the conclusion after that, and in that way you can say that Nishan cannot catch the ball because his distance covered by him is 24.4 and he is at 30 meter distance. I hope you understand this maths perfectly. If you have any doubt or any problem, you can contact with your subject teacher, or you can ask me if you have any problem. And thank you for being with me in the full lecture.